Hey everybody, Dr. Segrin here, and this one I'm gonna have to film at home because we done got frozen here in Texas, and school has been canceled for a week and a half, but we'll be starting up tomorrow. So I thought I would take a moment and talk a little bit about what actually happened in Texas because it relates to the topics that we're going to be talking about in environmental science. Principally what we have been talking about, which is where we get our electricity from. We had massive power outages all across Texas. People froze to death. It was horrible. I hope that you're safe, but we also had all kinds of water line breaks. The water went out. People's pipes burst in their houses and they still don't have water. Still, that also happened in the schools. That's why everything shut down. So it was a pretty big disaster. And obviously, this all relates to how we get our electricity, and also it relates to another topic that we're going to be covering here in a couple weeks, climate change and global warming. So let's get right into it. So we're going to call this lecture, What the Heck Just Happened in Texas? So like I was mentioning, there's two issues at play here. The first is the unusual weather. So it got unbelievably cold here, and I think parts of Houston were down below 10 degrees. That's pretty abnormal, and all kinds of records were set for low temperatures across the state of Texas, but also across the central United States as well. I mean, parts of Minnesota up here got to be negative 35. You know, that's pretty absurd. Even in Oklahoma and Dallas was in the negative degrees. Never heard of anything like that happening in my lifetime, certainly. And then the second part of the story is the energy infrastructure of Texas. And infrastructure is kind of a big word, but it's basically just means all the sort of built aspects of our cities and state that provide us with electricity and energy. So there were obviously many failures on that front as well. So let's tackle the first one first, and let's talk a little bit about the unusual weather. This is not the start of unusual weather in Texas, and I'll walk you through some of the other unusual weather events that we've had. So all of these events were in the last decade. So 10 years ago, 2011, we had what you could call a 100-year heat wave. This is the worst or the hottest temperatures you could expect to have over a 100-year period is roughly what that refers to. It's also another way to think about it is this would be a heat wave that has a 1% chance of happening for a given area. So obviously, you know, weather is changes all the time. There are hot days, there are cold days. Summers get hot, winters get cold. There's changes in weather all the time. But what is the most kind of pronounced and extended period of time where you have unbelievably hot temperatures in roughly a 100-year period? That would refer to a 100-year heat wave. So we had that. And this map here on the right shows where temperature records, max temperature records were broken in 2011 across the United States. And you can see a whole lot of temperature records were broken in Texas, not in Houston, but in a lot of Texas. Basically, you had max temperatures that were broken. So basically the hottest it's ever been for that location was recorded in 2011. And this was specifically on August 2nd. Pretty crazy. That year also brought an exceptional drought. So not only was it really, really hot that year, but also the amount of rain we got was pretty much the worst that you could expect in a 100-year period as well. So we had a 100-year heat wave, so it got really, really hot and also really, really dry. And unfortunately, all kinds of livestock died. We actually had a forest fire in Texas, which I never really heard of. And not only was it in Texas, it was on the Gulf Coast. This is Bastrop. Bastrop State Park is a nice area with pretty nice pine trees, a nice pine forest. but it typically gets around 35 inches of rain per year. So we're not talking about a dry, desert environment compared to the places typically that have wildfires in California. Those areas typically get something like 20 inches of rain per year. So this is like almost double in terms of rainfall that this area would typically get. But it got bone dry that summer and actually caught on fire. I think the stats I was looking at for Bastrop, which is where this forest caught on fire, its typical summer high temperature is around 95 degrees on average, which is pretty hot. We're talking about Texas. So that's July and August, typical day. During the middle of the day, the highest temperature it gets is typically 95 degrees. For that year, 2011, it got up to around the typical day. The average high temperature was a 102, so 7 degrees higher than normal. Really, really hot. That's the average. So it got hotter than that, but that was the typical day was 102 degrees that year for July and August. And normally it gets around 4 or 5 inches of rain for July and August, and it basically got 0 rain. So those conditions combined, the forest got unbelievably dry. I'm not entirely sure how the fire started, if it was man-made or natural, but pretty unheard of. This was 150 miles away from the Gulf of Mexico. Really not very far. Pretty unheard of. Then 5 years later, 2016, we had a 1,000-year flood. That was Hurricane Harvey. I think some areas it rained something like 50 inches of rain, which is over a year's worth of rain, fell in a matter of a day or two. Nobody's ever seen anything like that flood event. And actually, it was the most rainfall recorded for any storm in the history of the United States. So we call it a 1,000-year flood or a 500-year flood. Basically, we would not almost never expect something like this could happen. You would expect, from now back into the time of, the Vikings, you might have it happen once. That's what we're talking about, and it happened 5 years ago. And you might be scratching your head because didn't we already have some crazy flood event before that? Yeah, in 2001 we had Tropical Storm Allison, and I mean that's it's on the same intersection. It wasn't as devastating as Harvey, but it still represented a flood that we would only expect to have once every 100 years. And so now, within the last 20 years, we've had 2 floods that really, statistically speaking, should be impossible, yet they happened. Not impossible, but highly unlikely. But here we are. And then that brings us to 2021, where I think Greg Abbott, our governor, called this a 120-year storm. So we could expect to have this kind of cold weather front happen once every 120 years. And I've never seen, I'm 30, I've never seen, yes, occasionally it snows in Houston and it'll get below freezing for a night or so. But we had here at my house, I had snow fall on the ground Sunday night, and that snow was still there, I think by Thursday or Friday. It hadn't melted yet. That's how cold it stayed. It stayed cold throughout the year, throughout the week. That was, exceptional. There's never been anything like that for Houston. For the vast majority of the city's history, nobody's ever witnessed anything like that. And we didn't actually set a low temperature record, but we came pretty close. And lots of areas did set their low temperature record. The map on the top right shows all the dots represent places that set their record low February temperature. And insane, these green dots, so everything in that belt got below 0. So a pretty significant chunk of Texas got below 0, and parts of the panhandle up here, the blue dots, those got below -10 degrees. That's a crazy, crazy winter blast. So if you put all this together, what's happened in the last decade? 100-year heat wave, 100-year drought, 1,000-year flood, another 100-year winter storm, and if you go a decade before that, we had another 100-year flood. Statistically speaking, for all these things to happen, we would be talking 1 in 100,000, 1 in a million chance of all this stuff happening in the last 10 or 20 years. So is it possible that this is just random occurrences? Technically, yes, but I think lots and lots of people are picking up on the idea that strange things are happening with the weather. And when you see a pattern of strange weather that is reoccurring and getting more and more extreme, we would say that that is a representation that the climate is changing. So let's talk about that. So climate broadly just means the average temperatures and rainfall for a given area. That's representative of their climate. So the climate of Houston is typically pretty warm, and we have a decent amount of rain. We don't have as much rain as like a rainforest, but you know, we have like 30 to 40 inches of rain a year. It's a decent amount. When you start having changes where it's getting hotter and hotter, whether it's consistently or whether you're getting more extreme, so one year will be incredibly hot, one year incredibly cold, etc., that is a representation of the climate is changing. The average weather patterns are changing. It's not just one-off events. These are kind of connected, and the entire environment is slowly changing. We have mentioned the word global warming before. Global warming just refers to the overall tendency that the Earth is getting hotter, and that's because of man-made pollution. But climate change is the manifestation of global warming. So as you add more and more heat to Earth, remember, heat is going to obviously be tied to things like heat waves. So when you have a heat wave, you get record-breaking temperatures all over, you know, the country. That's pretty obvious that you can tie that to global warming. But you also, as you get things get hotter, you can have increased water stress on plants, and also different patterns of evaporation and rainfall. So on a really, really hot day, plants are going to lose more water. They're going to dry out. That's going to make them more vulnerable to forest fire. And then also heat is what drives evaporation in the ocean. So if you add more heat to the system, that could drive more evaporation to some areas. It could also drive, potentially it could dry out the area in certain other areas. That's going to be kind of random. So things like rainfall are going to be tied to heat. Over here on our right, you can see this is a hurricane, and typically what a hurricane is basically a really, really hot body of water. As it heats up, it generates evaporation. As this evaporation rises, it kind of swirls around and creates a hurricane. So when you look at a hurricane, that is entirely a manifestation of heat. If you put a bunch of heat into an ocean, it makes hurricanes. That's just how it works. Oceans are also, the entire movement of all the oceans and all the ocean currents are driven by heat. Water gets hot in certain areas, it pushes to the surface, hot rises. In areas where it's cooling off, it sinks, and that's what drives the entire circulation of the ocean. Along with salt and fresh water, so that there is an extra kind of component to that we'll talk about later. But ocean currents also are going to be influenced by global warming, and ocean currents have massive impacts on the climate of areas. And last but not least, and that's what just happened to us, wind currents are completely regulated by heat. Some parts of the world, as they heat up, the air expands and rises. Other parts of the world, air is contracting and cooling down. And so you get this circulation of heat around the world by the air currents. So when we talk about pollution potentially causing global warming, well, it is causing global warming. In the Earth, we think that just means that it's going to get hotter and hotter, but heat has a tendency to influence all these different things. And so it could get hotter, it could disrupt ocean currents, and hey, it's possible somewhere it could actually get colder. It could disrupt evaporation in some ways, where you get droughts in some areas. In some other areas, you might get crazy floods, or just different years, you get different conditions based off the circulation of all this heat that you're adding to the system. So that just goes to show you that, and we're going to talk a little bit more about what a cold front actually is, but a lot of times when it gets really, really cold outside, a lot of people go, oh, you know, where's that global warming now? It's so cold outside. Well, guess what? Even things like cold fronts are tied to heat on Earth and can absolutely be driven by global warming. So let's talk a little bit about that. We have, as part of Earth and this natural kind of heat exchange that's going on, we have these things called prevailing winds. And in our area of the Earth, we have these really strong prevailing winds called the jet stream, or a jet stream. And what these jet streams do is basically move air around the Earth like this. There's one that's spinning up here, there's one spinning down here, and each one of these jet streams actually also has counter motion going on at different levels in the atmosphere. It's a very complex system, but generally speaking, this is what's going on with wind in the United States on a typical jet stream. These are our typical wind currents. Sometimes these wind currents can get distorted. For example, this middle one, which is the strongest jet stream, the one that kind of sweeps across the middle of America, sometimes it'll get really warped and it'll do really weird things like this. Why does this happen? Usually because of uneven heat distribution occurring in certain areas. And these warpings of the jet stream have actually been tied to, they're increasing and have been tied to global warming. This is what happened. This is from February 15th to 2021. This is when all the snow was falling in Houston. This is what the jet stream looked like. Instead of going straight across, it got completely warped. Came all the way down like this. And what that happened is that this cold jet stream, which is called the polar vortex, which is normally up here and minding its own business around the North Pole, basically the air from the North Pole got to sweep all the way down into Texas. And so that frigid, negative, temperatures and low teens and whatnot temperatures that we experience, that was air that had actually come down from the North Pole. Air that should normally be up by, Alaska and northern Canada was down in Texas. That's why it got so cold. And it all had to do, again, this is all driven by heat. The only reason any of this is moving around is by heat. And let me show you what I mean by that. So here's another map that we can see. This is sort of the normal, what we would call the polar vortex. All the cold air is kept up here nice by the North Pole, and this warm air is basically kind of keeping it all in there. And if this is what the jet stream looks like, we have nice, warm, mild winter temperatures. However, when warmth pockets develop, say over the Pacific Ocean, they tend to want to push around differently, and they begin pushing up towards this North Pole. And in the process of that pushing forward, you get these counter arms that push down because you get this circulation. So you can kind of think of it as like Newton's third law, equal and opposite reaction. If you have an area that gets abnormally warm, all that heat has to go somewhere. And if it begins pushing in some direction, there's going to be a counter push somewhere else of cold air. And this is exactly what's been going on. This is actually this is from real data. And this, you can see, it's kind of hard to see exactly what's going on here on this map, but this is Texas here, and there's North America and all the states. This is the North Pole. And this is over here is actually Russia. So we're kind of looking down at the top of the world. So from the top, you can kind of see there's this warm current, the jet stream that kind of circulates the Earth here. And then there's also a colder polar vortex that's kind of circulating here. I just love this because you can see whenever there's an area that gets too warm, this warmth will kind of punch up into the cold. And when that happens, the cold air has to go somewhere else. And so you have this kind of, when the warm pushes up, the cold kind of has to push down. Every time you see one of those warm kind of punch ups, there's a big cold arm that comes down. And that's what a normal cold front is. Typically, this is perfectly normal to happen for the United States. It's part of the normal system that you have these sort of fluctuations in cold fronts. But when you have a really, really, really big arm of warm air that pushes up all the way to the North Pole, and actually this year in January, this warm arm actually managed to push up and completely split this cold air in half. And basically that had never happened before. And it seems that this crazy cold front in February was a result of that phenomenon happening. So all that is to say that, I could watch this all day, it's pretty mesmerizing, that even when it gets cold and we have cold fronts and cold wind blowing in, that cold air was typically, it didn't just magically appear. It got displaced. That cold air should be at the North Pole, and it got displaced by some big warm air current somewhere in the world, usually in the Pacific Ocean, pushing up into the North Pole, and all that cold air gets knocked down to us. So even our coldest temperatures can be tied to global warming. If parts of the Earth are getting too hot, we get these crazy disturbances of our weather patterns, of our wind patterns, of our climate. All right, so that covers the unusual weather aspect of what's going on here in Texas. And unfortunately, as we saw all these crazy extreme events happening in the last 10 years, I am firmly in the notion that this is not some one-off crazy one in a million thing that happened to us here in the last 10 years. That no, this is clearly evidence of a changing climate system of Earth, and that it's not going to go away. That Hurricane Harveys, these crazy cold fronts, crazy heat waves, crazy droughts, all of those are going to be part of our lives, potentially every decade moving into the future, or maybe even more frequent. We don't really know. As you keep dumping more and more heat into the system, all of these crazy things can get more and more crazy. So that brings us to our next topic, which is, okay, so things are getting more extreme. How are we kind of preparing for these things? And the answer there is not very well, clearly, based off what happened. To kind of explain the difficulties, everybody wants to blame somebody always here. I'm not really in that game. I just kind of wanted to see what actually happened. Was there anything that could be done about it? And I think the best way to start this explanation is actually something that happened to me at the grocery store the other day. I was shopping for a couple things. This was before the crazy winter blast, and I was over in the produce aisle, and there was like this Karen kind of whining to the manager that there was no celery. She was like, how can there not be celery? And I mean, I guess she kind of has a point. Pretty much every time I go to the grocery store, celery's there. And you don't really think about it. But in that moment, I kind of started thinking about it, like, why is there no celery? And in my mind, I started kind of playing all the things that have to happen to get celery to the grocery store, you know, in my chicken soup or whatever I'm making with my celery. Somewhere in the world, the celery has to be growing, typically California. So they can't be having crazy forest fires or any crazy weather events that could damage the celery crops. They need to have enough water for the celery to grow. They need to have fertilizer. Fertilizer comes from natural gas. Actually, it's derived from natural gas, and you know, it's made in a big plant. So all that has to be going right to get the fertilizer to the farmer to grow the celery. So all that has to go right for the farmer, and then hopefully he grows the celery, and then somebody has to, you know, he has to harvest the celery, take it to typically some kind of processing plant. It's not like it goes straight from the farm to the grocery store. It needs, usually the tops are chopped off, and if you buy the little stick, somebody has to go do that and package it and all that stuff, and then it has to get put on another truck and taken to the grocery store. And the grocery store has to know exactly how much celery to buy. If too many people buy too much celery too fast, they might run out. So they have to have exactly the right supply and demand all worked out at the grocery store. All those things have to go right. If anything goes wrong in any of that process, there's no celery on the shelf. And it kind of made me realize, kind of a miracle that there's ever celery on the shelf. And we're just so used to it, everything kind of working. But you know, maybe COVID shut down the processing center. The workers couldn't get in to process the celery. No celery on the shelf. There was a forest fire. Maybe there was a drought on the farming end. No celery. Maybe a whole bunch of people went and bought celery because they were making chicken soup because it was cold weather coming up. No celery. So the idea here is that our world has gotten unbelievably complex. Back in the olden days, if I wanted celery, you know, I needed to grow it on my farm, or there was not going to be any celery, or somebody down the street needed to grow it because that's where my celery came from. Now it's global, you know, supply chains, all this interconnected web of things that have to go right to get celery to my shelf. And I think our electricity works in similar ways. Lots of things kind of have to go right to get electricity to your house. So let's talk a little bit about that. There are lots and lots of things talking on, if you go on Facebook or whatever, lots of people are blaming the power outages on windmills and wind turbines. It is true there were some issues with wind turbines freezing or just not functioning very high. I mean, parts of the storm, there wasn't much wind. And actually, I'm kind of proud of Texas. Texas actually has a lot of wind energy that we get our electricity from. This is a graph showing the overall trend. And you can see we're just getting more and more wind energy each year. We have more wind energy than any other state in the country. So that's cool. But only about 17% of our electricity actually comes from wind. And during the winter storm, wind turbines were only working at about 20% efficiency. That is about what's expected during the winter, maybe a little bit lower. But regardless, if you're blaming all of the power outages experienced all across the state on this tiny little chunk, and you're not looking at all on this massive chunk, which is natural gas and coal, which makes up the majority of our electricity, you're not coming to the right conclusion. So yes, I'm not going to deny that wind turbines weren't very good at producing electricity during this winter storm, but they were not the main culprit of what happened. I do concede, I'm generally a proponent of wind energy, but let's say we did go tried to go, I don't know, 100% wind in Texas or something to power all of our electricity. Yeah, we would be totally screwed during a winter storm like this, because it would be worse than what happened now. So I will concede that. But for this particular storm, wind energy was not really that issue here. Let's talk about these other two bigger squares of our electricity, coal first and then natural gas, and talk about what exactly happened with these two. And this is kind of where the kind of celery analogy begins to surface. So coal in Texas actually, we use a lot of coal for electricity, but we don't actually have any coal here locally. I don't know of any coal mines in Texas. I don't know of any coal deposits or reserves in Texas. So we import our coal from other states, and that typically is carried by train. You can run trains in wintry and icy conditions, but it does make things a little bit more challenging. When railroad tracks freeze, the trains have difficulty stopping and all that stuff. So the coal supply was temporarily cut off. The good news is that usually we have a big reserve of coal near our power plants for such an occasion. Usually there are these big piles of coal that's kind of like stored in reserve. But unfortunately, those on that Sunday, we kind of had this icy rain, and before it started snowing, it got really, really cold, and these piles of coal basically just froze completely and were inaccessible, and you can't really burn something that's frozen. So yeah, that was a problem. And more importantly, the majority of our electricity here in Texas comes from natural gas. And the process of getting electricity from natural gas is complex, a little bit like the celery. It's got to move around. A lot of things have to be going right to get natural gas from the ground to a power plant and then that electricity to your house. So let's talk a little bit about that process. First, if you've ever seen something like this over in West Texas, this is a fracking well. This is how we get a lot of natural gas. We have this drill that goes down and cracks open all these rocks and sucks out all this oil and gas combination. This is a very dirty mixture at the time, and this cannot just be directly burned very efficiently. So typically what happens is after all this gas deposit gets sucked out of the ground, it gets put into a pipe, and that pipe moves over to a refinery. And a refinery is basically how we clean up this dirty mixture into nice components like gasoline and kerosene and natural gas, which is methane, and propane, and the things that we use to make plastic, and the things for tar and all that stuff. If you've ever been over to here in Houston, if you've ever been over to like Pasadena or Baytown, Channelview, all you see is this stuff. This is a refinery. And it's unbelievable. If you ever have a chance to just stop and look at it, the number of pipes going all which it's just like this massive network of pipes. And unfortunately, natural gas, usually when it's put in these pipes, it's put under pressure, and it's pretty sensitive to temperature. So as it gets colder and colder, the natural gas will actually flow and move slower and slower. And so all of these pipelines began getting colder and colder, and I don't think natural gas freezes at like -200. So it probably didn't completely freeze, but it did slow to a crawl. And some of these other pipes are all about cooling, and so some of these pipes have water and stuff, and those pipes might have completely frozen and broken and all that stuff. Plus, you need to have a staff, so people actually work here, and they need to be able to get to the work to do their job and make sure everything is going on safely. And if that can't happen, then it needs to shut down. And so all these things happened at the refineries. Assuming that all goes well, then the natural gas needs to move through another pipeline. And again, these pipelines were getting really, really cold during the winter storm. So the gas wasn't moving as fast and the supply was slowing down. Then it gets to the power plant where it's burned, and in the process, it spins a turbine, which creates electricity. It's kind of like a generator. And then I didn't see any issues with actual power lines going down due to ice or anything like that. It didn't get that cold. But you can see that a lot of things actually have to go right to get the gas from the ground cleaned up and to the power plant, burned, and then made into electricity. And many things basically failed during the winter storm. Pipes froze, they got cold, the natural gas slowed down. People that work at all these places couldn't get to work because it was freezing and they couldn't drive their cars outside. All that stuff happened, and it was the main culprit in terms of why you lost power during the storm. Now, are there natural gas plants and refineries and drilling that happen in really, really cold areas? Yes. You can design it to all withstand cold temperatures. You still might have some staffing issues in terms of getting people actually to work to operate all the equipment, but technically it could have all been built better. And that is something I think that we all need to think about is, are we all, to build it all better is more expensive, which means we would have to pay more for our electricity. Is it worth it to pay more for electricity in order to get all these things actually functional? A wide variety of weather events, particularly when we consider climate change, all this stuff might get worse and worse and worse over time. I think yes, absolutely. But that is a decision that we didn't really make. And then last but not least, we can also talk about Texas in general. We haven't had what I would call a hard freeze in over 30 years, basically my entire lifetime, where it got below zero, or not, where it got below freezing, and we had snow and it stayed below freezing day after day after day after day. We haven't had something like that in 30 years. And I think we got a little bit spoiled. Yes, we've been having global warming and have had really mild winters for the most part over the last several decades. Yes, you get the occasional cold front where it might dip down, but overall, we haven't had anything too crazy happen. And in the meantime, we have 10 million more people now in Texas than we did 30 years ago. And a lot of those people live in homes that were built to not the best building standards, and frankly, weren't built very smartly. Lots and lots of these people live in suburbs. As the cities grew and grew, people, thought it was too crowded and they wanted to have their own place. And we built basically, if you go to Katy or Pearland, there's just huge houses out there. They're basically mansions, but they're not like multi-million-dollar mansions like there would be in the city. They're kind of like budget mansions. So people wanted mansions, but they didn't want to pay mansion cost. So you have these huge homes that require tons of heating, and they don't have very high quality pipes. They don't have very high quality insulation. A lot of the hot water heaters were built in the attic, which froze. And all of these issues just had to do with kind of poor city planning, poor regulation, and just kind of, what did people think was going to happen with all this? Not to mention, when you put all these mansions, talking about other catastrophic events, this area that we're looking at here in this picture that's covered in these mansions, suburban mansions, that used to be a forest or a grassland. And when it rained, all that water would get soaked up by the ground or the forest or the plants. And what we've effectively done is basically covered up our entire natural ecosystems with, mansions and concrete. And so all that water has nowhere to go, and that's why we get floods. So there are, on top of the climate change, crazy weather patterns, and on top of the crazy nature of our supply chains and how difficult it is actually to get electricity, kind of like celery, to your home, is a pretty convoluted process that depends on a lot of moving parts and is very streamlined, but it's not very resilient to crazy stuff. And then on top of that, we have made ourselves even less resilient by really just building very, very poor designed houses. So I don't know. Did I answer what happened in Texas? Probably. It was a little long-winded. It's a complex issue. What does the future hold? I don't know. I guess we'll have to wait and find out, but it doesn't seem like we're heading in a good direction. But that was it. That was my explanation of what the heck happened in Texas with the winter storm. I hope you stayed safe. I hope you guys are all okay. And I'll talk to you guys later. See ya.